Hi, welcome to the Calculus 1 lecture series. And we are in the unit number 3, application of differentiation. And today we're going to start lecture number 21. And this one's here is we're going to talk about is indeterminate form and the L'Hopital's rule. So this is a kind of, you might think this is kind of the weird place to put this sections here is because this is back to the limit problems, right? So it's supposed to be our first unit for the limits of the functions here. The reason why we put over here is the main things for this units is the application of the differentiations. So one of the big topic in this unit is we try to find the graph of the functions, right? So that's why in the previous several lectures, we talk about how to define the increasing, decreasing, and the critical point, and where the function going to bend the concave up and where function going to bend the concave down here. And now the next things here, of course, when we do the graph, and we also sometimes we worry about want to find the asymptotes, right? So the asymptote, we have a vertical asymptote and a horizontal asymptotes here. So how about, like when we try to find the vertical asymptote and then we try to let x approach to some values, and if our function and have like 0/0 is indeterminate form, so how do I decide what will be the vertical asymptote? How do I decide the asymptotes here? So that's why the author put this lecture is kind of like in this unit here. So some people say, why we not talk about that in the first unit when we talk about the limits? So basically they put over here is because we want to see, when we try to do the graph is when we work on the asymptote, we run into the problems, right? So we have indeterminate forms here. Okay, so now let's go to our lecture notes here. Okay, so the L'Hopital's rule for the 0/0s here. Okay, so we talk about the motivation why we want to have the L'Hopital's rule, because when we try to find the limit x approach to some values here. So for examples here, so this is the one we say, okay, so if my limit x approach to a, right? So then if you have of f of x and the gx, let's assume here. So how about if you let the x approach to a, so f of x will approach to 0, g of x will approach to 0. So I know the 0/0 is not determined. It's indeterminate. I don't know what is the value. So how do I do it? Okay, so the whole idea about the L'Hopital's rule, and let me show you a graph to show you what is the whole idea about the L'Hopital's rule. So I think that from the graph, maybe you will get a better idea. So why we talk about that. Okay, so let's say here I have A here. All right, so this is my A. And then I have like f of x here. Let's say let's see here. So like my, let's see here. Let me get a color. So, okay, how about this is my f of a. Well, so let me get a better graph. I see you don't think I have a, okay, so let's see here. So let's see here if this is my f of a, right? So here, this is f of a. This is f of x. And also, let's see here if I have, like this functions here, I have like a g of x here, okay? So like you see, when the x approach to zeros, right? So both of them, what happens here? The both of them going to approach to zero. So if you find when the f of x function, when the x approach to a, then f of x will approach to 0. The same way, when this one's here approach to A, Gx will approach to 0. So we're going to have the 0 over 0 situations here. So what is the L'Hopital's rule? So L'Hopital's rule tell us, say, okay, if you approach the, let me do this one, get a little bit better curves here. Okay, so then we'll be able to draw better. Okay, so let's see here. Let me hope I can draw smooth ones here. Okay, so let's see here, right? Okay, let's see, it's way better. Okay, so now what is it? Let's say, okay, if you just approach to the function, f of x will be equal to 0, gx will be equal to 0. So what it says, hey, how about, let's take a look at, so if at this one's here, and then if I find the tangent line for these curves here, right? So this dot lines here, this is the tangent line for the gx function. And then the same ways here, if I put the tangent line for the f of x here. So just like we talked before, when the, when the x very close, so like in these regions, right? So when the x getting very close to the, the A, and then the ratio for the f of x and the gx, because we said the linearization, right? So this areas here are going to be very close to here. This area going to be very close to here. So we know the ratio of the f of x value and the g of x value should be very close to the ratio of the tangent line, the slope of the tangent lines here, right? So that's why in here, then we know the slope. So this one's here is what we know the slope is what f prime x, correct? And so here, this is what, this is g prime x here. So what is, so this is what is the, the L'Hopital's rule tell us, they say, hey, when the f of x and gx, they both approach to 0, 0, this is indeterminate. Then the L'Hopital's rule say, hey, this one's here, right? So when x approach to A, and this is f of x gx, then because I know the linearization, so this one will be very close to the tangent line slope, then we say, hey, these ratios here will be very close to the f prime x and the g prime x here. So now you see for these functions here, right? G prime x, definitely, this is not the zero slope. This is not the zero slope. So my limit, I can find the limit. So the limit will be existing here. You see here? Okay, so now how about if you have, okay, so how about if you have like a functions here is a limit x approach to A and f of x and g of x here. How about if they get to the infinity over infinities here? Then you say, oh boy, so what we can do? Then based on the ideas, right? So this is the f of x. So how about so this one I can switch that, right? So this is x approach to A, and I can switch. This is 1 over gx, and this is 1 over f of x, right? And now what is this one going to approach to? This one going to approach to 0, and this one going to approach to 0. So I know then you can take the derivative. So it's the same way. So now it's the same things, because if you do a little changes here, so this one will say, hey, by the L'Hopital's rule, then the x approach to A, you can just take the derivative of the function, and then the ratio will be the same as here. Okay, so be very careful. So these ones here, we say L'Hopital's rule, right? So it's only dealing with the 0 over 0 and infinity over infinity. So the second part of this lecture, so we're going to talk about is how about, if you have another type of the indeterminate form. So what is the other indeterminate forms here? For example, one of the very common is 0 over 0. So what is that? Right, or is 0 times infinity. So what is that? So we're going to use the same L'Hopital's, the similar way. We're just going to manipulate the equation to become to the 0 over 0 and the infinity over infinity. All right. Okay. Do you get it? Okay. So now let's take a look here, right? So in fact, the L'Hopital's rule is really pretty easy here, right? And be very careful here, right? So the original is 0 over 0, infinity over infinity. Then you can take the derivatives here, right? So if the other type of the indeterminate form, then we need to talk about what do we need to do in order to get it. Okay, so now if you say here, x approach to 2, right? So you always put it into your function first. It's 2 squared, so it's 0. 3 times 2 is 6. 6 minus 6 is 0. So this is 0 over 0. Then you say, oh, okay, so I can apply the L'Hopital's rule. Okay, so the L'Hopital's rule, what does it tell you? That means you will be the same as x approach to 2. Then will just be the ratio of its derivative. So what is here? This is 2x. So what is here? This is 3, right? All right. So now, okay. So that's what is this one's here. So then x approach to 2. So what you will have here? So you will have a 4/3, right? Okay. Okay. Now the next one's here. This is the x approach to the 0 from the right-hand side. Okay, if x approach to the 0 from the right-hand side, so I know the natural log x is here. So the natural log x here will approach to what? Will approach to the negative infinities, right? And then you have a negative sign, so the whole thing will approach to infinity. And then here, this is 1 over 0, so the bottom will approach to what? The bottom will approach to infinities as well, correct? Okay, and now, okay, so now we can do is, so because this is infinity over infinity, so what we can do here, we can do is using the what? We can using the L'Hopital's rules, right? So say, okay, so let's use the L'Hopital's rule. So I can take the derivative, on the top and on the bottoms here. So what is the natural log? You take a derivative is 1 over what? Is 1 over x. So the bottoms here, this is x to the negative 2 on bottom, right? So you take the derivative of what is here. This is negative 2 x to the what? Negative 3 here. So this is limit x approach to 0. Okay, so let's simplify it a little bit. Approach to 0 from the right-hand side. And this is negative 1 over x. This is negative 2 x over 3. Then the negative cancel. So it will be, of course, don't forget, don't forget you said the limit, the x approach to 0. And then this is 1 over x times the 2. The x over what? X over 3 here, right? So the x over 3, and then what you can do here, so here you will see here, you'll say, oh, okay, so now here cancel is 2. So it will be equal to limit x approach to 0 and 2 to the x squared. So what is the answer here? It's 0 here. All right. Okay. So now let's take a look at this one. This is the limit x approach to 0, sine x. Do you remember, like in the previous unit and special when we tried to introduce the formula for the sine function's derivative, we said, hey, let's take it for granted. We say this one is once, right? We say in that time I said, I'm not going to show you the proof. I'm going to show you later. And now this is what I can show you why this is once, right? So in that time we say, let's just take it and accept it as the series. So let's take a look at this one, why this is 1. So sine x approach to 0. So this one approach to what? It's 0. X approach to 0. This is zeros, right? So we know this is 0 over 0. Then by the L'Hopital's rule, then what I can do is here, I can take the derivative top and take the derivative bottom. So the sine x is a cosine x, and the x take derivative is 1. Then in here, you will get a cosine 0 over 1. And I know what is cosine 0 is 1, right? So this is 1 over 1. So it's once here. All right. So this is, that's why it's pretty easy to prove it, right? By using the L'Hopital's rule. And now you understand why in that time I told you just remember it. And now here we are going, we'll be able to prove it. Okay, so now let's take a look the number 4 here, right? So this is x approach to infinity. So here I'm going to have an infinity. Then e to the x, so of course this is infinity. So I'm going to get the infinity over infinity. What can I do here? I can do the L'Hopital's rule because infinity over infinity, I don't know what is that. Okay, so the L'Hopital's rule tell me I can take the derivative on the top. So the derivative on the top will give me 6x. The derivative on the bottom, the ex is still be the self. Now let's take a look here. We said, okay, so x approach to infinity again. So what is this one's here? This one is still is infinity, right? So when this one approach to infinity, what is this one? Still is infinity. Oh, wow. So it's still is infinity over infinity. So I did not solve my problems here. So I say, okay, let's try to take a look at the L'Hopital's rule one more time here, right? So this is x approach to the infinity. And now let's take a look at the derivative. So this is 6 and this is ex here. Now let's take a look at this one. Okay, so this one's here, the 6, so this will be 6, right? Now the x approach to the infinity. So what is the bottom here? The bottom is infinity. So what is the 6 over infinity? Is zeros here. So for the function, you can apply the L'Hopital's rules many times here, right? So till you reach the, the answers here. Okay, so now in here we talk about like the several, we talk about a couple indeterminate forms. So we talk about is 0 over 0. And infinity over infinities, right? So those are the two we can apply the L'Hopital's rule. Then we have several others, right? Several other indeterminate form. And then how do we do that? Okay, so let's first take a look. Is the infinity over the power infinity? This is the indeterminate or determinate? So for these ones here, the infinity to the infinity power, so that means that you are getting to where? So infinity go for the infinity power. This is a determinant. So this is going to be the infinities, right? So this is a determinant. Okay, so we also have several other ones. We also is a determinant. So first things we know is 0 over infinity, because infinity is going to approach to this one going to this one the whole fraction approach to 0. So this will be approach to 0. So this is determinant, right? So this is a determinant. Then also the same way, if I have an infinity over 0, and this is going to the infinity, so this is a determinant. Okay, so we have infinity plus infinity. This is a determinant. Okay, so now we have several other forms. We are not a determinant here. So let's try to list the form is not a determinant. Then we are going to do several examples here to go over these forms here, right? So let's first list the form is not a determinant. So the first one is here, if I have a limit my x approach to some value, I have f of x and times gx. So how about if one of them going to be 0 and times infinity? So the 0 times infinity, this is, we know is not a determinant, okay? So the second one we have is like a limit x approach to a. How about if I have f of x minus gx? And then here, this is infinity minus infinities here. Okay, so this is not a determinant. Okay, so now let's take a look here. The another one here. So this is limit x approach to a. And this is f of x, and then have exponents, the gx. Okay, so this one's here, if the limit will be 0 to the 0 power. So those are indeterminate, okay? And then the next one's here, this is x approach to a. There is the same exponents again, so this is gx. How about if you have this is 1 to the infinity? So this one is indeterminate here, all right? So the last one's here, this is x approach to a. You have another form, this is f of x gx here. So if this one's here is infinity to the 0 powers here, right? So those are the 5, the form is indeterminate here, all right? So our next video, well, I'm going to show you how to determine. All right, so what type of manipulation we need to do. So in order to change it to a form, we'll be able to use the L'Hopital's rules here. Okay, let's stop here and we'll continue in our second videos here. All right, okay, bye. Talk to you later. All right. Okay, so